Unit 7, Lesson 1, Positive and Negative Numbers. Number 1, A. Is a temperature of negative 11 degrees warmer or colder than a temperature of negative 15 degrees? Negative 11 degrees is warmer than negative 15 degrees. B. Is an elevation of negative 10 feet closer or farther from the surface of the ocean than an elevation of negative 8 feet? Negative 10 feet is farther from the surface of the ocean than negative 8 feet. C. It was 8 degrees at nightfall. The temperature dropped 10 degrees by midnight. What was the temperature at midnight? 8 minus 10 is negative 2. So it would be negative 2 degrees. Or we could look at it as 8 plus a negative 10, and that also would be negative 2. So the temperature at midnight would be negative 2 degrees. D. A diver is 25 feet below sea level. After he swims up 15 feet towards the surface, what is his elevation? 25 feet below sea level, that would be like negative 25. And then he swims up 15 feet. That would be like plus 15. So negative 25 plus 15 would be 10 feet below sea level, or negative 10. Number 2, A. A whale is at the surface of the ocean to breathe. What is the whale's elevation? The whale's elevation is sea level. B. The whale swims down 300 feet to feed. What is the whale's elevation now? Well, he went down 300 feet from sea level. So that's like going from 0 down 300 feet. So that would be negative 300 feet or 300 feet below sea level. C. The whale swims down 150 more feet. What is the whale's elevation now? If the whale started at 300 feet below sea level and then he swam down another 150 feet, that would be 450 feet below sea level, or negative 450 feet. D. Plot each of the 3 elevations as a point on a vertical number line. Label each point with its numeric value. The whale started at 0, which would be sea level. He went down 300 feet, which would have brought him to 300 feet below sea level, or negative 300 feet. Then the whale went down an additional 150 feet, making a total of 450 feet below sea level, or negative 450 feet. Number 3. Explain how to calculate a number that is equal to 2 1/10 over 1 5/10. 2 1/10 over 1 5/10 is the same as 21 over 15. I just made each of those values 10 times greater by multiplying the both of them by 10. That helped me get rid of the decimal point, allowing me to deal with whole numbers instead of decimals. 21 over 15, or 21 divided by 15. And 21 divided by 15 is 1 4/10, or 1.4. Number 4. Write an equation to represent each situation and then solve the equation. A. Andre drinks 15 ounces of water, which is 3/5 of a bottle. How much does the bottle hold? Use X for the number of ounces of water the bottle holds. 15 equals 3/5 X, or 15 equals 3/5 times X. That can be rewritten as 3/5 times X equals 15. To solve for X, I'm going to divide 15 by 3/5. 15 divided by 3/5 will give me the value for X. 15 divided by 3/5 equals X. To solve that, I'm going to multiply by the reciprocal of 3/5. So 15 times 5/3. 15 times 5/3 is 25. The bottle holds 25 ounces of water. B. A bottle holds 15 ounces of water. Jada drank 8 5/10 ounces of water. How many ounces of water are left in the bottle? Use Y for the number of ounces of water left in the bottle. 15 ounces in the bottle minus 8 5/10 ounces of water that Jada drank will give you Y, the number of ounces that are left in the bottle. and 15 minus 8 5/10 equals 6 5/10. So there are 6 5/10 ounces of water left in the bottle. C. A bottle holds Z ounces of water. A second bottle holds 16 ounces, which is 8/5 times as much water. How much does the first bottle hold? 8/5 Z, or 8/5 times Z, equals 16. We can solve for Z by dividing 16 by 8/5. So 16 divided by 8/5 will equal Z, or the amount that the first bottle holds. We can do this by multiplying by the reciprocal of 8/5. 16 times 5/8 equals 10. The first bottle holds 10 ounces of water. Number 5. A rectangle has an area of 24 square units and a side length of 2 3/4 units. Find the other side length of the rectangle. Show your reasoning. Well, I know the area is equal to base times height. We can find the missing side length by dividing the area by the known side length. So area divided by base will give us the unknown side length. 24 divided by 2 3/4 can be rewritten as 24 divided by 11/4. 24 divided by 11/4 can be done by multiplying by the reciprocal of 11/4. 24 times 4/11 equals 96/11. So the missing side length is 96/11, which can be rewritten as 8 8/11. The missing side length is 8 8/11 units. Unit 7, Lesson 2, Points on the Number Line. Number 1. For each number, name its opposite. A. -5. The opposite of -5 is +5 or 5. B. 28. The opposite of +28 or 28 is -28. C. -10 4/10. The opposite of -10 4/10 is +10 4/10 or 10 4/10. D. 875 thousandths. The opposite of 875 thousandths is -875 thousandths. E. 0. 0 is its own opposite. F. -8003. The opposite of -8003 is +8003 or 8003. Number 2. Plot the numbers -1 and 5/10, 3/2, -3/2, and -4/3 on the number line. Label each point with its numeric value. Since -1 and 5/10 has the same value as -3/2, they have the same location on the number line. To the right of it, or slightly closer to 0, would be -4/3, and then on the positive side of 0, we have 3/2. And since 3/2 is the same as 1 1/2, you'll notice that its location on the number line is exactly between 1 and 2. Number 3. Plot the following points on a number line. -1 and 5/10. In blue, you can see -1 and 5/10 to the left of 0, halfway between -1 and -2. The opposite of -2. Well, the opposite of -2 is +2. So you'll notice 2 units to the right of 0 on the number line, I've plotted the opposite of -2, which is +2. The opposite of 5/10. Well, the opposite of 5/10 would be -5/10. So you'll notice halfway between 0 and -1 on the number line, I've plotted -5/10. And then finally, -2. 2 units to the left of 0 on the number line, I've plotted -2. Number 4. A. Represent each of these temperatures in degrees Fahrenheit with a positive or negative number. I, or let's call that 1. 5 degrees above 0. That would be 5 or +5. 2. 3 degrees below 0. That would be -3. Number 3. 6 degrees above 0. That would be a positive 6 or 6. 4. 2 3/4 degrees below 0. That would be a negative 2 3/4. B. Order the temperatures above from the coldest to the warmest. Well, the furthest below 0 in this case would be negative 3, then negative 2 3/4, then 5, and then the warmest would be 6. Number 5. Solve each equation. A. 8x equals 2/3. That's the same as 8 times x equals 2/3. We need to solve for x. And in order to solve for x, we're going to divide 2/3 by 8. 2/3 divided by 8 will equal x. In order to do 2/3 divided by 8, we're going to multiply by the reciprocal of 8 over 1. 2/3 times 1 over 8 equals x. And 2/3 times 1/8 is 1/12. X equals 1/12. B. 1 1/2 equals 2x. That's the same as 2x, or 2 times x, equals 1 1/2. That can be rewritten as 3 over 2 divided by 2 over 1 equals x. We can solve for x by multiplying by the reciprocal of 2 over 1. 3/2 times 1/2 equals x. And 3/2 times 1/2 equals 3/4. So x equals 3/4. C. 5/2 equals 2/7. That can be rewritten as 2/7 divided by 5 over 1 equals x. We can solve for x by multiplying by the reciprocal of 5 over 1. That would be 2/7 times 1/5 equals x. And 2/7 times 1/5 equals 2/35. So 2/35 equals x, or x equals 2/35. D. 1/4 x equals 5. That can be rewritten as 5 divided by 1/4 equals x, which is the same as 5 over 1 divided by 1/4 equals x. And to solve for x, we'll multiply by the reciprocal of 1/4. So 5 over 1 times 4 over 1 equals x. And 5 over 1 times 4 over 1 equals 20 over 1. So x would equal 20. E. 1/5 equals 2/3 x. That can be rewritten as 1/5 divided by 2/3 equals x. We'll have to multiply by the reciprocal of 2/3. That would be 1/5 times 3/2. And 1/5 times 3/2 equals 3/10. So x equals 3/10. Number 6. Write the solution to each equation as a fraction and as a decimal. A. 2x equals 3. That can be rewritten as 3 divided by 2 equals x, which is 3/2 or 1 1/2. X equals 1 1/2 or 1 5/10. B. 5y equals 3. That can be rewritten as 3 divided by 5 equals y. 3 divided by 5 can be rewritten as 3 over 5, or 3/5. So 3/5 equals y. 3/5 is the same as 6/10. 3 times 2 equals 6, and 5 times 2 equals 10. So 3/5 equals 6/10. And 6/10 is the same as a decimal, 0.6. So y equals 3/5 and y equals 6/10. C. 3/10 z equals 9/1000. That can be rewritten as 9/1000 divided by 3/10 equals z. And 9/1000 divided by 3/10 is the same as 9/100 divided by 3. And 9/100 divided by 3 is 3/100. So z equals 3/100. As a fraction, it would be 3 over 100, and as a decimal, 3/100 would be 0.03. Number 7. There are 15 and 24 hundredths centimeters in 6 inches. A. How many centimeters are in 1 foot? Well, 6 inches times 2 equals 1 foot. So 15 and 24 hundredths centimeters times 2 is going to equal 1 foot. So there are 30 and 48 hundredths centimeters in 1 foot. That's just less than 30 and a half centimeters in 1 foot. B. How many centimeters are in 1 yard? Well, since there's 3 feet in 1 yard, we multiply 1 foot times 3. That gives us 1 yard. Next, we would multiply 30 and 48 hundredths centimeters times 3 to get 1 yard. And 30 and 48 hundredths centimeters times 3 is 91 and 44 hundredths centimeters. So there's 91 and 44 hundredths centimeters in 1 yard. Unit 7, Lesson 3, Comparing Positive and Negative Numbers. Number 1. Decide whether each inequality statement is true or false. Explain your reasoning. A. -5 is greater than 2. Well, obviously that's false, but if it's not so obvious to you, I drew a number line and I put -5, 5 units to the left of 0, and +2, 2 units to the right of 0. The further to the left, the smaller the number's value. So 2 is actually greater than -5. B. 3 is greater than -8. That's true, because 3 is further to the right on the number line, making it greater than -8, and -8 is further to the left on the number line, making it less than 3. C. -12 is greater than -15. That's also true, because -12 is further to the right on the number line than -15. And the number that's further to the right on the number line always has a greater value than any number that's to its left on the number line. D. -12 and 5/10 is greater than -12. That's false, because -12 and 5/10 is further to the left on the number line, making it smaller than -12. The value for -12 and 5/10 is less than the value for -12. Number 2. Here is a true statement. -8 and 7/10 is less than -8 and 4/10. Select all the statements that are equivalent to -8 and 7/10 is less than -8 and 4/10. Well, I did not select A, because -8 and 7/10 is not further to the right on the number line than -8 and 4/10. I also didn't select D, because -8 and 7/10 is not greater than -8 and 4/10. I also didn't select E, because -8 and 4/10 is not less than -8 and 7/10. I selected B, C, and F. B because -8 and 7/10 is further to the left on the number line than -8 and 4/10. I selected C because -8 and 7/10 is less than -8 and 4/10. And I selected F because -8 and 4/10 is greater than -8 and 7/10. Number 3. The table shows 5 states and the lowest point in each state. Put the states in order by their lowest elevation from least to greatest. California's lowest elevation is -282, or 282 feet below sea level. So I'd put that as the lowest. Louisiana is also in the negatives, with its lowest point being at -8, or 8 feet below sea level. So Louisiana would go second on the list. The next lowest would be New Mexico. New Mexico's lowest elevation is 2,842 feet. Wyoming would be next, with its lowest elevation being 3,099 feet above sea level. And then finally Colorado would be the highest elevation. Its lowest point is 3,350 feet above sea level. Number 4. Plot each of the following numbers on the number line. Label each point with its numeric value. 4/10, -1 and 5/10, -1 and 7/10, negative 11/10. On the number line, the furthest to the right would be 4/10. That's the greatest number of the four numbers that they gave us. Just to the left of the 0, or left to negative 1, is negative 1 and 1/10. That's the next largest number out of the group. To the left of negative 1 and 1/10 is negative 1 and 5/10. And then finally, between negative 1 and 5/10 and negative 2 is negative 1 and 7/10. Number 5. Each lap around the track is 400 meters. A. How many meters does someone run if they run 2 laps? Well, if one lap around the track is 400 meters and they run 2 laps, that would be 2 laps times 400 meters, or 800 meters. 5 laps, that would be 5 times 400, or 2,000 meters. And then finally, X laps, that would be 400 meters times X number of laps, or 400X. B. If Noah ran 14 laps, how many meters did he run? 400 times 14, or 14 times 400, and that would be 5,600 meters. In green at the bottom, I broke it down as 14 times 400 equals 7 times 400 plus 7 times 400. 7 times 4 is 28, so 7 times 400 is going to be 2,800. So 2,800 plus 2,800 equals 5,600, or 5,600. C. If Noah ran 7,600 meters, how many laps did he run? 7,600 divided by 400, that's the same as 76 divided by 4. You see, if we made 7,600 100 times smaller, it would be 76. And if we made 400 100 times smaller, it would be 4. 76 divided by 4 is 19. And 7,600 divided by 400 would also be 19. 7,600 meters equals 19 laps. Number 6. A stadium can seat 16,000 people at full capacity. A. If there are 13,920 people in the stadium, what percentage of the capacity is filled? Explain or show your reasoning. 13,920 divided by 16,000 is 87 hundredths, or 87 over 100, or 87%. With 13,920 people in the stadium, that would be 87% of the capacity. B. What percentage of the capacity is not filled? Well, 100% of the capacity minus 87% of the capacity equals 13% of the capacity. 13% of capacity is not filled. Unit 7, Lesson 4, Ordering Rational Numbers. Number 1. Select all the numbers that are greater than negative 5. All numbers to the right of negative 5 on the number line are greater than negative 5. I made a number line, and you can see that I placed the numbers on the number line. So all the numbers that are to the right of negative 5 will be greater than negative 5. Negative 4, negative 1, 1/7, 1 3/10. So I circled A, D, E, and F. Number 2. Order these numbers from least to greatest. 1/2, 0, 1, negative 1.5, negative 1/2, and negative 1. So I made my number line. To the right of the 0, I have 1/2. To the right of 1/2, I have 1. To the left of my 0, I have negative 1/2. To the left of negative 1/2, I have negative 1. And to the left of negative 1, I have negative 1.5. Order from left to right on the number line, and the numbers will be in least to greatest order. So negative 1.5 is the smallest number in this group, and positive 1 is the largest number in this group. Number 3. Here are the boiling points of certain elements in degrees Celsius. List the elements from least to greatest boiling points. I'm going to list it with the least boiling point at the top and the greatest boiling point at the bottom. You could do it from left to right if you want. The smallest number on this list belongs to hydrogen. Its boiling point is at negative 252 and 87 hundredths. So I'm going to put that at the top for my lowest boiling point. The next lowest boiling point belongs to fluorine. That's negative 188 and 1/10. So I'll put that just under hydrogen. These numbers are getting greater. If you were going left to right, the left side would be the smallest number, the right side would be the largest number. But I'm going top to bottom, with the smallest number on the top and the greatest number at the bottom. Let me mention that all these numbers are in degrees Celsius. They're their boiling points in degrees Celsius. So the next number on this list will be argon at negative 185 and 8/10 degrees Celsius. As these numbers are getting greater, the next temperature is krypton at negative 153 and 2/10 degrees Celsius. And finally, the highest boiling point out of all the elements on this list is chlorine at negative 34 degrees Celsius. Number 4. Explain why 0 is considered its own opposite. Opposites are equal units from 0. Example, 4 and negative 4 are both 4 units from 0. Since 0 is 0 units from 0, and 0 is neither positive nor negative, 0 is neutral and is considered its own opposite. Number 5. Explain how to make these calculations mentally. A. 99 plus 54. Well, remember, we're trying to do this mentally so we don't have to use a paper and pencil or a calculator. It's easy to make 99 into 100. You just add 1 from the 54 to 99 and that makes it 100. So now you have 100 plus 53 equals 153. B. 244 minus 99. This one's a little bit different because we're subtracting. I chose to add 1 to each of the numbers, so I'm working with easier numbers. 245 minus 100 equals 145, which is the same value as 244 minus 99. It's just easier for me to do mentally without a paper and pencil. C. 99 times 6. I chose to make it 100 times 6, and 100 times 6 is going to be greater than 99 times 6. It's going to be one group of 6 greater than 99 times 6, so I have to remove one group of 6. So 100 times 6 is 600, and 600 minus one group of 6 equals 594. So 99 times 6 equals 594. D. 99 times 15. 99 is almost 100, so I'm going to make it 100. 100 times 15 is going to be one group of 15 larger than 99 times 15. And 100 times 15 equals 1500. Now we have to remove one group of 15 to make the value 1485. So 99 times 15 equals 1485. Number 6. Find the quotients. A. 1/2 divided by 2. 1/2 divided by 2 can be rewritten as 1/2 divided by 2 over 1. And to find the answer, we're going to multiply by the reciprocal of 2 over 1. 1/2 times 1/2 equals 1/4. B. 2 divided by 2. 2 divided by 2 equals 1. We don't need to overcomplicate it, but if you wanted to, you could write 2 over 2 or 2 divided by 2 to get the answer. C. 1/2 divided by 1/2. That can be rewritten as 1/2 times 2 over 1 because we need to multiply by the reciprocal of 1/2. So 1/2 times 2 over 1 equals 2 over 2 or 1. D. 38/79 divided by 38/79. Well, anything divided by itself equals 1, but if we wanted to complicate it, we could rewrite it as 38/79 times the reciprocal of 38/79, which is 79/38. 38/79 times 79/38 equals 1 over 1 or 1. Number 7. Over several months, the weight of a baby measured in pounds doubles. Does its weight measured in kilograms also double? Explain. Imagine the weight is X, or unknown, and it doubles in a month. Its weight doubled would be 2X, or 2 times X. So yes, the weight doubles no matter what the measurement is. Unit 7, Lesson 5. Using negative numbers to make sense of contexts. Number 1. Write a positive or negative number to represent each change in the high temperature. A. Tuesday's high temperature was 4 degrees less than Monday's high temperature. 4 degrees less would be -4. B. Wednesday's high temperature was 3 5/10 degrees less than Tuesday's high temperature. That would be -3 5/10. C. Thursday's high temperature was 6 5/10 degrees more than Wednesday's high temperature. That would be +6 5/10. D. Friday's high temperature was 2 degrees less than Thursday's high temperature. That would be -2. Number 2. Decide which of the following quantities can be represented by a positive number and which can be represented by a negative number. Give an example of a quantity with the opposite sign in the same situation. A. Tyler's puppy gained 5 pounds. Gaining 5 pounds would be worth +5, and the opposite of that would be -5. B. The aquarium leaked 2 gallons of water. Leaking 2 gallons of water would be -2, and the opposite of -2 is +2. C. Andre received a gift of $10. Receiving a gift of $10 would be +10, and the opposite of that would be -10. D. Kieran gave a gift of $10. Giving a gift of $10 would be -10, and the opposite of -10 is +10. E. A climber descended 550 feet. Descending would be negative, so -550, and the opposite of -550 is +550. Number 3. Make up a situation where a quantity is changing. A. Explain what it means to have a negative change. The temperature decreased from 90 degrees to 85 degrees. B. Explain what it means to have a positive change. My checking account is finally in the positive. Yesterday I owed the bank $10, but after I deposited my $200 paycheck today, my account balance is $190. C. Give an example of each. Negative change. The temperature going down is an example of a negative change. Positive change. A rise in temperature is a positive change. Number 4. A. On the number line, label the points that are 4 units away from 0. I drew a number line, and I put points to the right, which would represent +4, and I put points to the left, which would represent -4. Both +4 and -4 are 4 units away from 0. B. If you fold the number line so that a vertical crease goes through 0, the points you label would match up. Explain why this happens. Because each positive number has an opposite negative value, which is the same distance from 0. C. On the number line, label the points that are 5/2 units from 0. What is the distance between these points? I forgot to put my points in there, so make sure that you put the points. To the right of the 0 at 5/2, I've labeled it 5/2, which represents 5/2. Instead of placing a little line right there, place a point. And then at 5/2 to the left of the 0, I have -5/2. And again, on that line underneath -5/2, make sure you put a point. From the point, located underneath -5/2 all the way to the point located underneath 5/2, it would be 10/2. The distance from point to point would be 10/2, and 10/2 is equal to 5 units. So the distance between these 2 points are 5 units. Number 5. Evaluate each expression. A. 2 to the 3rd power times 3. That's 2 times 2 times 2 times 3. Or 8 times 3. And 8 times 3 is 24. B. 4 to the 2nd power over 2. That equals 4 times 4 over 2. Or 16 over 2. And 16 over 2 means 16/2, or 16 divided by 2, which equals 8. C. 3 to the power of 1. I want you to take a guess on that one and we'll come back to it later. D. 6 to the power of 2 divided by 4. That's the same as 6 to the power of 2 over 4, or 6 times 6 divided by 4. And 6 times 6 is 36. 36 divided by 4 equals 9. E. 2 to the 3rd power minus 2. That's the same as 2 times 2 times 2 minus 2. And 2 times 2 times 2 is 8, and 8 minus 2 equals 6. F. 10 to the 2nd power plus 5 to the 2nd power. That's the same as 10 times 10 plus 5 times 5. 10 times 10 is 100. 5 times 5 is 25. So 100 plus 25 equals 125. Going back to C, 3 to the power of 1. You took your guess, and 3 to the power of 1 is 3. Unit 7, Lesson 6, Absolute Value of Numbers. Number 1. On the number line, plot and label all numbers with an absolute value of 3/2. 3/2 is the same as 1/2. The absolute value of -1/2 is the same as 1/2 because it's 1/2 units from 0. And the absolute value of +1/2 is 1/2 because it's 1/2 units away from 0. Number 2. The temperature at dawn is 6 degrees Celsius away from 0. Select all the temperatures that are possible. -12 degrees Celsius would be 12 degrees away from 0, so that's not possible. -6 degrees Celsius is 6 degrees away from 0. On the number line, -6 is 6 units away from 0 to the left, so B is possible. C, 0 degrees. Nope. 0 degrees is not 6 degrees away from 0, so that's not possible. D. 6 degrees Celsius. That is possible because 6 degrees is 6 degrees away from 0. And E. 12 degrees Celsius. Nope, 12 degrees Celsius is 12 units away or 12 degrees away from 0, so that wouldn't be possible. The absolute value of 6 is 6 units away from 0, and the absolute value of -6 is 6 units away from 0. So B and D are possible. Number 3. Put these numbers in order from least to greatest. The absolute value of -2 7/10, 0, 1 3/10, the absolute value of -1, and 2. When we put them in order from least to greatest, the smallest number value would be 0. The next greatest would be the absolute value of -1, because the absolute value of -1 is 1 unit away from 0. So underneath that in red I wrote 1 to represent its value. The next number would be 1 3/10, then the next value would be 2, and then finally the greatest value would be the absolute value of -2 7/10. The absolute value of -2 7/10 is 2 7/10 because it's 2 7/10 away from 0. Number 4. Elena donates some money to charity whenever she earns money as a babysitter. The table shows how much money, D, she donates for different amounts of money, M, that she earns? A. What percent of her income does Elena donate to charity? Explain or show your work. In this chart, she shows different amounts of donations for different amounts of money earned. I selected to use $30 of money earned and the $3.60 donated, and I have it here represented in my chart. The money is $30 and the donation is $3.06 or $3.60. I just wrote it as 3 6/10. I chose these numbers because I can easily turn $30 into $10 by dividing it by 3. I turned that $30 into $10 so that I could multiply that 10 times 10 to make it $100. I would do the same thing to the other side. $3.60 divided by 3 equals 1 2/10 or $1.02 or $1.20. So when she earns $10, she donates $1.20. Now multiply the dollar side by 10 and you get $100. For every $100 she earns, she would donate $12 because $1.20 times 10 is $12. If she donates $12 for every $100 she earned, that's 12%. She donates 12% of her income to charity. If it was confusing for you to use a table, you could just use the amount of the donation divided by the money earned, and that would give you the percent. B. Which quantity, M or D, would be the better choice for the dependent variable in an equation describing the relationship between M and D? Explain your reasoning. Since the amount of the donation depends on the amount of money earned, D would be the dependent variable. C. Use your choice from the second question to write an equation that relates M and D. My equation is D equals 12/100 times M. Number 5. How many times larger is the first number in the pair than the second? A. 3 to the power of 4 is how many times larger than 3 to the power of 3? 3 to the power of 4 is 3 or 3 to the power of 1 times larger than 3 to the power of 3. B. 5 to the third power is how many times larger than 5 to the second power? 5 to the third power is 5 or 5 to the first power times larger than 5 to the second power. C. 7 to the 10th power is how many times larger than 7 to the 8th power? 7 to the 10th power is 49 or 7 to the second power times larger than 7 to the 8th power. D. 17 to the power of 6 is how many times larger than 17 to the power of 4? 17 to the power of 6 is 289 times larger than 17 to the power of 4. 17 to the power of 6 is also 17 to the power of 2 times larger than 17 to the power of 4. E. 5 to the power of 10 is how many times larger than 5 to the power of 4? 5 to the power of 10 is 15,625 or 5 to the power of 6 times larger than 5 to the power of 4. Number 6. Lynn's family needs to travel 325 miles to reach her grandmother's house. A. At 26 miles, what percentage of the trip's distance have they completed? So it can be written as 26 over 325, or it can be written as 26 divided by 325. Either way, it's going to give you the percentage of the trip completed. 26 divided by 325 equals 8/100, and 8/100 is 8%. After 26 miles, Lynn's family has traveled 8% of the trip. B. How far have they traveled when they have completed 72% of the trip's distance? I created a chart with miles on the left and percent of the trip on the right. After 26 miles, they've completed 8% of the trip. I got that information when I solved problem A. I know that 8 times 9 equals 72, so 26 times 9 will give me the number of miles that they've traveled after 72% of the trip. 26 times 9 equals 234, so 72% of the trip is 234 miles. C. At 377 miles, what percentage of the trip's distance have they completed? Well, I know that 377 is more than 325, so they've gone more than 100% of the trip. I can still figure this out by dividing the number of miles traveled by the number of miles that they need to travel. So 377 divided by 325 equals 1 1600ths, which is the same as 11600ths or 116% of the trip. Unit 7, Lesson 7, Comparing Numbers and Distance from Zero. Number 1. In the context of elevation, what would the absolute value of -7 feet mean? Its meaning would be 7 feet below sea level. Number 2. Match the statements written in English with the mathematical statements. A. The number -4 is a distance of 4 units away from 0 on the number line. That would match with number 4. The absolute value of -4 equals 4. B. The number -63 is more than 4 units away from 0 on the number line. That would match with number 1. The absolute value of -63 is greater than 4, because the absolute value of -63 is 63. C. The number 4 is greater than the number -4. That matches with statement 5. 4 is greater than -4. D. The numbers 4 and -4 are the same distance away from 0 on the number line. That matches with statement 6. The absolute value of 4 is equivalent to the absolute value of -4. E. The number -63 is less than the number 4. That matches with statement number 2. -63 is less than 4. F. The number -63 is further away from 0 than the number 4 on the number line. That matches with statement 3. The absolute value of -63 is greater than the absolute value of 4. Number 3. Compare each pair of expressions using greater than, less than, or equal to. A. -32 is less than 15. B. The absolute value of -32 is greater than the absolute value of 15. C. 5 is greater than -5. D. The absolute value of 5 is equal to the absolute value of -5. E. 2 is greater than -17. F. 2 is less than the absolute value of -17. G. The absolute value of -27 is less than the absolute value of -45. H. The absolute value of -27 is greater than -45. Number 4. My received and spent money in the following ways last month. For each example, write a signed number to represent the change in money from her perspective. A. Her grandmother gave her $25 in a birthday card. That would be +25 or 25. B. She earned $14 babysitting. $14 babysitting would be positive 14 or 14. C. She spent $10 on a ticket to the concert. Spending $10 would be negative 10. D. She donated $3 to a local charity. Donating $3 would be negative 3. Number 5. Here are the lowest temperatures recorded in the last 2 centuries for some U.S. cities. Temperatures are in degrees Fahrenheit. A. Which of these states has the lowest record temperature? California's Death Valley would have the lowest record temperature, as Death Valley's lowest temperature was negative 45, and negative 45 is further below zero than any of the other temperatures. B. Which state has a lower record temperature, Florida or Georgia? Georgia's lowest temperature is negative 17 degrees. Florida's lowest temperature is negative 2 degrees. Negative 17 degrees is further below zero than negative 2. Georgia would have a lower record temperature than Florida. C. Which state has a lower record temperature, Connecticut or Illinois? Connecticut's lowest temperature is negative 37, or 37 below zero. Illinois' lowest temperature is negative 36, or 36 below zero. Connecticut would have the lower temperature, as negative 37 is further below zero than negative 36. D. How many more degrees colder is the record temperature for Georgia than for Florida? I created a number line to illustrate this answer. On the right-hand side, you have 0, or 0 degrees. To the left of 0, you have negative 2, which represents Florida's lowest temperature. 15 degrees to the left of negative 2, you have negative 17, which represents Georgia's coldest temperature. There's 15 degrees between negative 2 and negative 17. Number 6. Find the quotients. A. 24 thousandths divided by 15 thousandths. 24 thousandths divided by 15 thousandths is the same as 24 divided by 15, and 24 divided by 15 is 1 6/10. B. 24 hundredths divided by 15 thousandths. 24 hundredths divided by 15 thousandths would be the same as asking how many times does 15 go into 240. I've made the 15 thousandths 1,000 times bigger, and I made the 24 hundredths 1,000 times bigger, simply by moving the decimal 3 places to the right. And 240 divided by 15 equals 16. C. 24 thousandths divided by 15 hundredths. I'm going to move the decimal to the right 2 places to make the 15 hundredths 100 times larger. So now I'm asking, how many times does 15 go into 2 4/10? The 24 thousandths turned into 2 4/10 because I also needed to make that side 100 times larger by moving the decimal point 2 places to the right. In order to keep the division problem the same, if I make one number larger, I'd have to make the other number larger. For example, in this case, I made the 15 hundredths 100 times larger, so I had to make the 24 thousandths 100 times larger. 15 goes into 2 0 times. 15 goes into 24 once. 1 times 15 is 15, and the difference between 24 and 15 is 9. Bring down the 0. 15 goes into 90 6 times, and 6 times 15 is 90, with 0 remaining. 24 thousandths divided by 15 hundredths equals 16 hundredths. D. 24 divided by 15. 24 divided by 15 is 1 6/10. Unit 7, Lesson 8, Writing and Graphing Inequalities. Number 1. At the book sale, all books cost less than $5. A. What is the most expensive a book could be? The highest price a book could be would be $4.99, since all the books cost less than $5. B. Write an inequality to represent costs of books at the sale. All books are less than $5. C. Draw a number line to represent the inequality. Here I've drawn a number line and I have labeled $5 and I have an open circle right at $5 with the arrow pointing to the left, meaning all books are less than $5. Number 2. Kieran started his homework before 7 o'clock p.m. and finished his homework after 8 o'clock p.m. Let H represent the number of hours Kieran worked on his homework. Decide if each statement is definitely true, definitely not true, or possibly true. Explain your reasoning. A. H is greater than 1. That would be definitely true because he started his homework before 7 o'clock and finished his homework after 8 o'clock, which is more than 1 hour. B. H is greater than 2. That's possibly true since he worked more than 1 hour and we don't know what time after 8 o'clock he stopped. It is possible that he could have been working longer than 2 hours. C. H is less than 1. That's definitely not true because he worked from before 7 o'clock to after 8 o'clock, and this is for sure over 1 hour. So it is not possible for him to have worked less than 1 hour. D. H is less than 2 hours. That's possible. It would depend on the start time and the end time. Number 3. Consider a rectangular prism with length 4 and width and height d. A. Find an expression for the volume of the prism in terms of d. 4 times d squared, or 4d to the power of 2. B. Compute the volume of the prism when d equals 1, when d equals 2, and when d equals 1/2. When d equals 1, it would be 4 times 1 to the power of 2, or 4 times 1 times 1, which is 4. So the volume would be 4 units to the third power, or 4 units cubed. When d equals 2, it would be 4 times 2 times 2, which equals 16. So the volume would be 16 units to the third power, or 16 units cubed. When d equals 1/2, it would be 4 times 1/2 times 1/2, which equals 1. So the volume would be 1 unit to the third power, or 1 unit cubed. Number 4. Match the mathematical statements with the statements written in English. All of these statements are true. A. The absolute value of -12 is greater than -15. That matches with 3. The distance between -12 and 0 on the number line is greater than -15. B. -15 is less than -12. That matches with number 5. The number -15 is less than the number -12. C. The absolute value of -15 is greater than the absolute value of -12. That matches with statement number 1. The number -15 is further away from 0 than the number -12 on the number line. D. The absolute value of -12 equals 12. That matches with statement number 2. The number -12 is the distance of 12 units away from 0 on the number line. E. 12 is greater than negative 12. That matches with statement 6. The number 12 is greater than the number negative 12. F. The absolute value of 12 equals the absolute value of negative 12. That matches statement number 4. The numbers 12 and negative 12 are the same distance away from 0 on the number line. Number 5. Here are 5 sums. Use the distributive property to write each sum as a product with 2 factors. A. 2a plus 7a. The common factor is a, so I'll pull the a out and keep it on the outside of the parentheses. So it'll be a times 2 plus 7. B. 5z minus 10. The common factor here would be 5, so I'm going to pull the 5 out and have it on the outside of the parentheses. 5 times z minus 2, because 5 times z equals 5z, and 5 times 2 equals 10, or 5 times minus 2 equals minus 10. C. C minus 2c to the second power. The common denominator is c. I'm going to pull out the c, put it on the outside of the parentheses. On the inside of the parentheses, I'll keep 1 minus 2c, because c times 1 is the same as c, and c times 2c is the same as 2c squared, or c times minus 2c is the same as minus 2c squared. D. R plus R plus R plus R. I pulled out 2r as the common denominator with 1 plus 1 on the inside of the parentheses. So 2r times 1 plus 1, because 2r times 1 is 2r, and 2r times the other 1 would be 2r. So 2r plus 2r would be 4r. There's a wide variety of ways to set this one up. I just chose this one. E. 2x minus 1/2. I pulled out 1/2 as the common denominator, so 1/2 on the outside times 4x minus 1, because 1/2 times 4x equals 2x, and 1/2 times minus 1 equals minus 1/2. Unit 7, Lesson 9, Solutions of Inequalities. Number 1. A. Select all numbers that are solutions to the inequality k is greater than 5. I selected 6, 5 2/10, and 5 1/100. B. Draw a number line to represent this inequality. K is greater than 5. So I drew a number line, and I have an open circle underneath 5 with the arrow pointing to the right. Number 2. A sign on the road says, speed limit 60 miles per hour. A. Let S be the speed of a car. Write an inequality that matches the information on the sign. I wrote S is less than 60. I prefer S is less than or equal to 60, but we haven't gotten to the less than or equal to sign yet. B. Draw a number line to represent the solutions to the inequality. I drew my number line, and I have a colored in point or a closed circle underneath 60 with my arrow pointing to the left. C. Could 60 be a value of S? Explain your reasoning. Yes, the limit is 60 miles per hour. Any speed 60 miles per hour or below is within the limit. Number 3. One day in Boston, the high temperature was 60 degrees Fahrenheit and the low temperature was 52 degrees. A. Write one or more inequalities to describe the temperatures, T, that are between the high and the low temperature on that day. They specifically said that we need to describe the temperatures T that are between the high and the low temperatures on that day. So we're not going to include the high temperature or the low temperature. it'll be temperatures that are between them. T is less than 60 and T is greater than 52. B. Show the possible temperatures on a number line. So I drew a number line and I have an open circle underneath 52 and an open circle underneath 60 with a red line between the two. Now I did this so that I could show the temperatures that are between 52 and 60, not including 52 and 60. Number 4. Select all the true statements. I selected A because -5 is less than the absolute value of -5 because the absolute value of -5 is 5. I selected D because 4 is less than the absolute value of -7 because the absolute value of -7 is 7. And I selected E because the absolute value of -7 is less than the absolute value of -8. Number 5. Match each equation to its solution. A. X to the 4th power equals 81. I selected B, or 3. 3 to the 4th power is 3 times 3 times 3 times 3, which is the same thing as 9 times 9, or 81. B. X squared equals 100. I selected D, or 10. 10 squared equals 10 times 10, or 100. C. X to the 3rd power equals 64. I selected C, or 4. 4 to the 3rd power equals 4 times 4 times 4, which is the same as 16 times 4, or 64. D. X to the 5th power equals 32. I selected A, or 2. 2 to the 5th power equals 2 times 2 times 2 times 2 times 2, which is the same thing as 4 times 4 times 2, or 16 times 2, which is 32. Number 6. A. The price of a cell phone is usually $250. Elena's mom buys one of these cell phones for $150. What percentage of the usual price did she pay? She paid $150 compared to the usual price of $250. We can figure out the percentage that she paid by dividing 150 by 250, and that is 6/10, or 60 hundredths, which is the same thing as 60%. $150 is 60% of $250. B. Elena's dad buys another type of cell phone that also usually sells for $250. He pays 75% of the usual price. How much did he pay? The unknown price that he paid divided by 250 would equal 75%. So X divided by 250 equals 75 hundredths. We can figure that out by multiplying 75 hundredths by 250. That'll give us the price he paid. 75 hundredths times 250 is $187.50. He paid $187.50, which was 75% of the usual price of the phone. Unit 7, Lesson 10, Interpreting Inequalities. Number 1. There's a closed carton of eggs in Mai's refrigerator. The carton contains E eggs, and it can hold 12 eggs. A. What does the inequality E is less than 12 mean in this context? It means that there are less than 12 eggs in the carton. B. What does the inequality E is greater than 0 mean in this context? There are some eggs in the carton. C. What are some possible values of E that will make both E is less than 12 and E is greater than 0 true? E could be any value from 1 to 11. Number 2, here is a diagram of an unbalanced hanger. A. Write an inequality to represent the relationship of the weights. Use S to represent the weight of the square in grams and C to represent the weight of the circle in grams. This inequality can be expressed as C is greater than S or S is less than C. B. One red circle weighs 12 grams. Write an inequality to represent the weight of one blue square. This inequality can be expressed as S is less than 12. C. Could 0 be a value of S? Explain your reasoning. No, 0 could not be the value of S because S is greater than C and must have a value. Number 3. Tyler has more than $10. Elena has more money than Tyler. Mai has more money than Elena. Let T be the amount of money that Tyler has. Let E be the amount of money that Elena has. And let M be the amount of money that Mai has. Select all statements that are true. I selected B. M is greater than 10 because Mai has more money than Elena. Elena has more money than Tyler. And Tyler has more than $10. I selected C. E is greater than 10 because Elena has more money than Tyler, and Tyler has more than $10. I selected D. T is greater than 10 because Tyler has more than $10. And finally I selected F. T is less than E. Elena has more money than Tyler, so Tyler has less money than Elena. Number 4. A. Jada is taller than Diego. Diego is 54 inches tall. That's 4 feet 6 inches. Write an inequality that compares Jada's height in inches, J, to Diego's height. This inequality can be expressed as J is greater than 54. B. Jada is shorter than Elena. Elena is 5 feet tall. Write an inequality that compares Jada's height in inches, J, to Elena's height. 5 feet is 60 inches because 5 times 12 is 60. This inequality can be written as J is less than 60. Number 5. Which is greater, -9 over 20 or -5/10? Explain how you know. If you get stuck, consider plotting the numbers on a number line. I can compare -9/20 to 5/10 pretty easily because I notice that I can multiply the 20 times 5 to get 100, and I multiply 9 times 5 to get 45. So now I have -45/100. And still, I have a fraction on one side and decimals on the other, and it's not so obvious. But I can turn this -45 over 100 into -45/100 just by writing it as a decimal. When -45/100 is written as a decimal, it becomes much easier to compare to -5/10, and I've rewritten -5/10 as -50/100. So when we compare -45/100 with -50/100, it gets even easier if I put it on a number line. -50/100 is smaller than -45/100. It's further to the left. So -9/20 is greater than -5/10. Number 6. Select all the expressions that are equivalent to 1/2 to the power of 3. 1/2 to the power of 3. That's the same as 1/2 times 1/2 times 1/2. So we certainly can select A. And 1/2 times 1/2 times 1/2 equals 1/8. So we can select E. 1/2 times 1/2 times 1/2 is the same thing as 1 over 2 to the third power, so we can select B. We cannot select C because 1/3 to the power of 2 is the same as 1/9, and we cannot select D because its value is 1/6, and we're looking for a value of 1/8. Unit 7, Lesson 11, Points on the Coordinate Plane. Number 1. A. Graph these points on a coordinate plane. -2 and 3, 2 and 3, -2 and -3, and 2 and -3. I color-coded each set of these points so that you can see where they end up on the coordinate plane. The first number in your set of points moves along the x-axis. That's the horizontal axis, right or left. The positive number, you'd count to the right. A negative number, you'd count to the left. The second number in your points moves along the y-axis or the vertical axis. A positive number would move up and the negative number would move down. Take a look at the blue point in the upper left-hand quadrant. Starting at the origin, or the exact spot where the x-axis and the y-axis intersect, I counted 2 places to the left for -2, and then I counted up 3 places for +3. So the coordinates for the blue point are -2 and +3. Now look at the green point in the upper right-hand quadrant. I've started at the origin and I've moved 2 places to the right, and then I moved 3 places up. That would mean that the first coordinate was +2 and the second coordinate was +3. For the red point, start at the origin, move left 2 units for -2, and move down 3 units for -3. And the purple point would be to the right 2 units for +2 and down 3 units for -3. And the shape that this makes after we connect the dots is a rectangle. Number 2, write the coordinates of each point. If you take a look at this graph, they're counting by 2's starting at the origin. 2, 4, 6, 8. To the right, and -2, -4, -6, and -8 to the left. So each square is worth 2 units. The point for A is exactly halfway between the origin, or 0, and 2. So halfway between 0 and +2 would be +1. So the first coordinate for A would be +1. And the point for A is directly located on the x-axis, or the horizontal axis. That means that it hasn't moved up or down the vertical axis. So the second coordinate would be 0. B is located directly on the y-axis. That means it didn't move to the right along the x-axis, and it didn't move along the x-axis to the left. So the first coordinate for B would be 0. And then it's located exactly between -2 and -4, which would be -3. So the coordinates for B would be 0 and -3. C is located directly above the -6 on the x-axis. So it's moved 6 spaces to the left, and then it moved up exactly between the 4 and the 6. So that would be 5. So 6 to the left along the x-axis, that would be -6, and 5 up along the y-axis, that would be +5. So the coordinates for C would be -6 and +5. D, start at the origin and move 3 units to the left along the x-axis and 5 units down along the vertical axis or the y-axis, and you'll find the point for D. The coordinates would be -3 and -5. The point for E is located 1 unit to the left along the x-axis for -1, and then 4 units up the vertical axis or the y-axis at 4. So the coordinates would be -1 and +4. Number 3. These 3 points form a horizontal line. Coordinates -3.5 and 4, coordinates 0 and 4, and coordinates 6.2 and 4. Name 2 additional points that fall on this line. Here you can see the horizontal line that it formed, and I highlighted it in yellow. I went ahead and put a couple more points on there with coordinates -8 and 4 and 10 and 4. So on the left side in purple you see -8 and 4, and on the right hand side you see 10 and 4. For the first coordinate, you can put any number, as long as the second coordinate is 4. Some other examples of coordinates that would fall on this line would be 1 and 4, -1 and 4, 5 and 4, and -5 and 4. As long as the y-coordinate is 4, the point will fall on this line. Number 4. One night, it is 24 degrees Celsius warmer in Tucson than it was in Minneapolis. If the temperatures in Tucson and Minneapolis are opposites, what is the temperature in Tucson? I built a number line to help me figure this one out, and since the two temperatures are opposites and Tucson's warmer, I put Tucson on the right-hand side of the number line to represent a positive temperature, and I put Minneapolis on the left-hand side of the number line to represent a negative temperature. Since on that night Tucson was 24 degrees Celsius warmer than Minneapolis, I knew that there would be 24 degrees between Tucson's temperature and Minneapolis's temperature. This number line shows a pretty good picture, with Tucson's temperature being 12 degrees Celsius and Minneapolis's temperature being -12 degrees Celsius. You can see that they're both opposites and that there's 24 degrees between the two of them. The absolute value of -12 plus the absolute value of 12 is 24. So Tucson's temperature is 12 degrees Celsius, so I selected C. Number 5. Noah is helping his band sell boxes of chocolate to fund a field trip. Each box contains 20 bars, and each bar sells for $1.50. A. Complete the table for values of M. M stands for money collected. B stands for boxes sold. With 20 bars in one box selling for $1.50 each, 20 times $1.50 is $30. So each box would raise $30. One box sold would be $30, 2 boxes sold would be $60, 3 boxes sold would be $90. So basically, as the left-hand column increases by 1 unit, the right-hand column will increase by $30. So finally, 8 boxes sold would be $240. B. Write an equation for the amount of money, M, that would be collected if B boxes of chocolate bars are sold. Which is the independent variable and which is the dependent variable in your equation? The amount of money collected, M, would equal $30 per box times the number of boxes sold. So M equals 30B. And the dependent variable is M, the amount of money collected, and the independent variable is B, the number of boxes sold. C. Write an equation for the number of boxes, B, that were sold if M dollars were collected. Which is the independent variable and which is the dependent variable in your equation? The amount of money collected divided by $30 per box equals the number of boxes sold. So M over 30 equals B. The dependent variable is B and the independent variable is M. Number 6. Lynn ran 29 meters in 10 seconds. She ran at a constant speed. A. How far did Lynn run every second? 10 seconds divided by 10 equals 1 second. So if she ran 29 meters in 10 seconds, then we'd have to divide 29 by 10, and we would get 2 9/10 meters per second. If Lynn ran 29 meters in 10 seconds, then Lynn would run 2.9 meters in 1 second. B. At this rate, how far can she run in 1 minute? We can multiply 29 meters times 6 or 2 9/10 meters times 60. Both will be correct. 29 meters times 6 because Lynn ran 29 meters in 10 seconds. And 10 seconds times 6 equals 1 minute. So if we multiply 10 seconds times 6, we need to multiply the 29 meters times 6. 2 9/10 times 60 because Lynn runs 2 9/10 meters in 1 second, and 1 second times 60 equals 1 minute. Either way, Lynn runs 174 meters in 1 minute. Unit 7, Lesson 12, Constructing the Coordinate Plane. Number 1. Draw and label an appropriate pair of axes and plot the points. I designed both the horizontal axis and the vertical axis to be in increments of 1/5. Since each of the data points were in fifths, or no larger than the absolute value of 1 1/5, it was easy to fit all of the data points on this graph. For the first set of coordinates in blue, I moved along the x-axis to the right 1/5, which would be 1 of the squares, and then I went up 4/5, which would be 4 of the squares. And it's at that spot that I plotted the point for the first set of coordinates. For the second set of coordinates in green, I started at the origin, and I moved to the left 3/5, which would be 3 of the squares, and then I moved up 2/5, which would be 2 squares. And that's the location where I plotted my point for the second set of coordinates. For the third set of coordinates, I needed to go to the left 1 1/5. That's a total of 6/5 to the left, or 6 boxes, or 6 squares to the left. And then I went down 4/5, which is moving down 4 boxes or 4 squares. And that's where I plotted my point for the third set of coordinates. For the fourth and last set of coordinates, I moved to the right 1/5, and then I moved down 3/5, and that's where I plotted my point for the last set of coordinates. Number 2. Diego was asked to plot these points. What interval could he use for each axis? Explain your reasoning. When making each axis for his graph, he could use intervals of 50, since 50 is the greatest common factor of all the numbers other than 0. For example, the first set of coordinates, -50 and 0. He would just move 1 unit to the left and 0 units up or down. The second set of coordinates, +150. He would end up moving 3 units to the right and then 100. He would move 2 units up. Because 50 goes into 150 3 times, that would be 3 units to the right. And since 50 would go into 100 twice, that would be 2 units up. For the third set of coordinates, 200, well, 50 goes into 200 4 times, so that would be 4 units to the right. And then -100, that would be moving down 2 places or 2 units because 50 goes into 100 twice. Number 3. A. Name 4 points that would form a square with the origin at its center. The coordinates for those 4 points would be 1 and 1, -1 and 1, -1 and -1, and the last set of coordinates would be 1 and -1. By the way, this is just one example how you could form a square with an origin at its center. Here's a look at it graphed. I placed a tiny red dot at the center where the origin is. I plotted each of the points and I wrote their coordinates next to each one. B. Graph these points to check if they form a square. Well, I already graphed it and I showed you the graph, but let's take one more look at it so that we can see the square. Here's a look at it. It forms a square and you can see the origin inside the center. You can use your imagination as well to see how you could use other points that would also make a square. Number 4. Which of the following changes would you represent using a negative number? Explain what a positive number would represent in that situation. A. A loss of 4 points. That would be represented by using a -4. C. A loss of $10. That would be represented by a -10 or a -$10. B and D are not represented using a negative number because they're talking about a gain of yards or above sea level. I wouldn't represent either of those with a negative number. Explain what a positive number would represent in that situation. For A, a positive number would represent a gain of points, and for C, a positive number would represent a gain of money. Number 5. Jada is buying notebooks for school. The cost of each notebook is $1.75. A. Write an equation that shows the cost of Jada's notebooks, C, in terms of the number of notebooks, N, that she buys. I wrote $1.75 times N equals C, or C equals $1.75 times N. B. Which of the following could be points on the graph of your equation? Some of these fit perfectly into the cost to the number of books, and some of them fit perfectly into the number of books to the cost, and one of them doesn't fit at all. So the cost to the number of books would be $1.75 to one book, and the other one would be $17.50 to 10 books. And then the number of books to the cost, that would be 2 books for $3.50, and then the next one would be 5 books for $8.75. Number 6. A cornfield has an area of 28 6/10 acres. It requires about 15 million gallons of water. About how many gallons of water per acre is that? To figure this one out, I created a table with the left-hand column having the number of acres and the right-hand column having the number of gallons of water. 28 6/10 acres for every 15 million gallons of water. Since I'd like to know how many gallons of water per acre, I want to get this down to just 1 acre. So 28 6/10 acres divided by 28 6/10 equals 1. So I need to divide 15 million by 28 6/10. But they did say about how many gallons of water is that. So I don't need to divide it by exactly 28.6. I've decided to divide it by 30. 15 million gallons of water divided by 30. That's the same as 1,500,000 gallons of water divided by 3. Because I'm going to knock off one of the zeros on the top, which is the same thing as making 15 million 10 times smaller, and I'm going to knock off that zero on the bottom, which is the same as making 30 10 times smaller. 1,500,000 divided by 3 is a lot like 150 divided by 3. And I know 150 divided by 3 is 50. But 150 divided by 3 is a lot smaller than 1,500,000 divided by 3. In fact, it's 10,000 times smaller, so I have to remember to bring down these 4 zeros. So 1,500,000 divided by 3 is 500,000. So I will select C, 500,000. Approximately 500,000 gallons of water are needed for 1 acre of land. Unit 7, Lesson 13. Interpreting points on a coordinate plane. Number 1. The elevation of a submarine is shown in the table. Draw and label coordinate axes with an appropriate scale and plot the points. The horizontal axis, or the x-axis, will identify the time after noon in hours, and the vertical axis, or the y-axis, will represent elevation in meters. The horizontal axis is located at the top of this graph, and the vertical axis is represented on the left-hand side of this graph. On the top left-hand corner, you'll see a yellow 0, and that yellow 0 represents sea level. And then just above it you see a blue 100. That represents 100 meters above sea level. Underneath the yellow 0, or underneath sea level, you'll see increments of 100, negative 100, negative 200, negative 300, and so forth. That represents the amount of meters below sea level. The first set of coordinates is 0 and negative 567. The 0 stands for 0 time after noon hours, which means it's exactly at noon. And the negative 567 stands for meters below sea level. So when we start at the axis, the yellow 0, where the horizontal axis and the vertical axis intersect, we move to the right 0 units. So we stay right on that y-axis. Then for the negative 567, we slide down the y-axis and stop somewhere between negative 500 and negative 600 to represent negative 567. Now we'll have to go a little bit more than halfway between negative 500 and negative 600 because negative 567 meters below sea level is further down than negative 550 meters below sea level. And that's where we put our point. Remember, the first number in the coordinates is the amount that you're going to move along the horizontal axis, and the second number is the amount of units that you're going to move along the vertical axis. The second set of coordinates are 1 and negative 892, or 892 meters below sea level. So the number 1 represents 1 hour after noon, or 1 o'clock, and the negative 892 represents 892 meters below sea level. So that point is going to be plotted very close to negative 900. The submarine is almost 900 meters below sea level at 1 o'clock. So we move from the origin 1 unit to the right, and then move down almost to negative 900, and that's where we put our point. Try the rest on your own and pause the video to check your answers. Number 2. The x-axis represents the number of hours before or after noon, and the y-axis represents the temperature in degrees Celsius. So what this information is telling me so far, that the origin represents noon on the x-axis, and the origin represents freezing on the y-axis. Remember that the origin is your starting point. It's where your horizontal axis and the vertical axis intersect. A. At 9 a.m., it was below freezing. In what quadrant would this point be plotted? 9 a.m. is before noon, so we'd have to move to the left of the origin. And below freezing would be below freezing. So we'd move down, and that would put us in quadrant number 3. B. At 11 a.m., it was 10 degrees Celsius. In what quadrant would this point be plotted? 11 a.m. is still before noon, so we'd have to move to the left on the horizontal axis. 10 degrees Celsius would be above freezing because the freezing point for Celsius is 0 degrees, so we'd have to move up the y-axis, and that would put us in quadrant number 2. C. Choose another time and temperature, then tell the quadrant where the point should be plotted. If you come up with a positive time and a positive temperature, then your point would be plotted in quadrant number 1. If you come up with a negative time and a positive temperature, then your point would be plotted in quadrant number 2. A negative time and a negative temperature, your point would be plotted in quadrant number 3. A positive time and a negative temperature, the point would be plotted in quadrant number 4. For example, the coordinates negative 1 and positive 3, that point would be plotted in quadrant number 2 because you'd move to the left 1 unit and then you'd move up 3 units, and that would take you to quadrant number 2. D. What does the point 0, 0 represent in this context? The first 0 would represent noon, and the second 0 would represent freezing. So 0, 0 represents a freezing temperature at noon. Number 3. The inequalities h is greater than 42 and h is less than 60 represent the height requirements for an amusement park ride, where h represents a person's height in inches. Write a sentence or draw a sign that describes these rules as clearly as possible. The person's height must be taller than 42 inches and shorter than 60 inches. Number 4. Solve each equation. A. 3a equals 12. Since we're solving for a, we need to get the a to be 1a, so we're going to divide 3a by 3. Since we divided 3a by 3, we also need to divide 12 by 3. 3a divided by 3 equals 1a, and 12 divided by 3 equals 4. So 1a equals 4, which is the same thing as a equals 4. b. b plus 3 3/10 equals 8 9/10. Since we're solving for b and we have to get b alone, we need to subtract 3 3/10 from both sides. So b plus 3 3/10 minus 3 3/10 equals 8 9/10 minus 3 3/10. That leaves us with b all by itself and 5 6/10. So b equals 5 6/10. c. 1 equals 1/4 c. Since we're solving for c, we're going to have to multiply both sides by the reciprocal of 1/4, which is 4, or 4 over 1. 1 times 4 over 1, or 1 times 4, is 4, and the reciprocal of 1/4 times 1/4 equals 1. So we're left with 4 equals 1c, which is the same thing as 4 equals c, or c equals 4. d. 5 1/2 equals d plus 1/4. Since we're solving for d, we need to get d by itself, so we're going to remove 1/4 from both sides. So now we have 5 1/2 minus 1/4 equals d plus 1/4 minus 1/4. Well, d plus 1/4 minus 1/4 gets us back to d, which is why we did that in the first place, and 5 1/2 minus 1/4 is the same as 5 2/4 minus 1/4, and 5 2/4 minus 1/4 is 5 1/4. So 5 1/4 equals d, or d equals 5 1/4. e. 2e equals 6 4/10. Well, since we're solving for e, we need to get the e by itself. So we need to divide both sides by 2. 2e divided by 2 equals 6 4/10 divided by 2. 2e divided by 2 leaves us with 1e, and 6 4/10 divided by 2 leaves us with 3 2/10. 1e equals 3 2/10, and that's the same as e equals 3 2/10. Unit 7, Lesson 14, Distances on a Coordinate Plane. Number 1. Here are 4 points on a coordinate plane. A. Label each point with its coordinates. The coordinates for point K are -3 and +3. 3 to the left on the x-axis and 3 up along the y-axis. The coordinates for the point labeled x are 3 and 2. 3 to the right along the x-axis and 2 up along the y-axis. The coordinates for the point labeled M are -5 and -4. 5 to the left along the x-axis and 4 down along the y-axis. And the coordinates for the point labeled Y are 2 and -3. That's 2 to the right along the x-axis and 3 down along the y-axis. B. Plot a point that is 3 units from point K. Label it P. And I put -3 and 0. So 3 to the left along the x-axis and 0 up or down on the y-axis. There's many choices to choose from. This is just the one that I came up with. C. Plot a point that is 2 units from point M. Label it W. Again, there's a lot of choices, but the one that I came up with was -3 and -4. That's 3 to the left along the x-axis and 4 down along the y-axis. Number 2. Each set of points are connected to form a line segment. What is the length of each? A equals coordinates 3 and 5, and B equals coordinates 3 and 6. Well, we notice that the x-coordinate is the same. They're both 3, but the y-coordinate is different. The difference between 5 and 6 is 1, so the line segment is 1 unit in length. B. The point C has coordinates -2 and -3, and point D has coordinates -2 and -6. Their x-coordinates are both -2, but their y-coordinates are different. The difference between -3 and -6 is 3 units, so the line segment would be 3 units long. C. The coordinates for point E are -3 and 1, and the coordinates for point F are -3 and -1. Their x-coordinates are the same, but their y-coordinates are different, and the difference between 1 and -1 is 2 units, so the length of the line segment would be 2 units long. Number 3. On the coordinate plane, plot 4 points that are each 3 units away from point P, and point P is equal to coordinates -2 and -1. Write the coordinates of each point. First, I plotted the point P. I went 2 to the left along the x-axis and 1 down along the y-axis. They asked me to plot 4 points that are each 3 units away from point P. In blue, I have 1 point that is -5 and -1. In green, I have another point with coordinates -2 and +2. In red, I have another point with coordinates -2 and -4. And finally, the 4th point in purple has coordinates 1 and -1. Number 4. Noah's recipe for sparkling orange juice uses 4 liters of orange juice and 5 liters of soda water. A. Noah prepares large batches of sparkling orange juice for school parties. He usually knows the total number of liters, T, that he needs to prepare. Write an equation that shows how Noah can find S, the number of liters of soda water, if he knows T. Well, I noticed that for every 4 liters of orange juice, he uses 5 liters of soda water, totaling 9 liters of sparkling orange juice. So the amount of soda water is always going to be 5 liters out of 9 liters. So to figure out how much soda water he would need if he knew T, he would multiply 5/9 times T. So the equation would be S equals 5/9 T. B. Sometimes the school purchases a certain number, J, of liters of orange juice, and Noah needs to figure out how much sparkling orange juice he can make. Write an equation that Noah can use to find T if he knows J. T would equal 9/4 times J, or T equals 9/4 J. Number 5. For a suitcase to be checked on a flight instead of carried by hand, it can weigh at most 50 pounds. Andre's suitcase weighs 23 kilograms. Can Andre check his suitcase? Explain or show your reasoning. Note, 10 kilograms is just about 22 pounds. So they told us that 10 kilograms weighed just about 22 pounds. Since the suitcase can weigh at most 50 pounds, I need to turn the 22 pounds into 50 pounds, and I'm going to do that by turning it into 1 pound first. 22 pounds divided by 22 equals 1, or 1 pound. Since I divided the pounds by 22, or made it 22 times smaller, I also need to make the kilograms 22 times smaller, or divide 10 kilograms by 22. 10 divided by 22 is the same as 10 over 22. So 10 over 22 kilograms equals 1 pound. Next, I'm going to multiply the 1 pound times 50, so I can make the right-hand side equivalent to 50 pounds. 1 times 50 equals 50. And since I made the pounds side 50 times larger, I need to make the kilogram side 50 times larger. So 10 over 22 times 50 equals 500 over 22. And 500 over 22 means 500 divided by 22. So 500 divided by 22 equals 22 point something. I ran out of room while doing my division problem, and I thought to myself, well, the largest number that could possibly go in that box would be a 9. And then I thought to myself, well, 22.9 kilograms is less than 23 kilograms. So the answer would be yes. Andre can check his suitcase. By the way, 500 divided by 22 is 22.7272 repeated. So it is less than 23. Unit 7, Lesson 15. Shapes on the coordinate plane. Number 1. The coordinates of a rectangle are 3 and 0, 3 and -5, -4 and 0, and -4 and -5. A. What is the length and width of this rectangle? Well, the difference between a +3 and a -4 is 7. The difference between 0 and -5 is 5. So the length and width of the rectangle would be 7 and 5. B. What is the perimeter of the rectangle? With the length being 7 and the width being 5, we just add up the lengths and the widths. So 7 plus 7 plus 5 plus 5. The perimeter of the rectangle is 24 units. C. What is the area of the rectangle? The formula for finding the area of a rectangle is base times height. The base 7 times the height 5 equals 35 units squared. The area of the rectangle is 35 units squared. Number 2. Draw a square with one vertex on the origin and plot -3 and 5, and the square should have a perimeter of 20. It needs to be a square. It needs to have one vertex. It needs to have one vertex on the origin. It needs to have one vertex on the origin. It needs to have one vertex on the origin. It needs to have one vertex on the origin. It needs to have one vertex on the origin. It needs to have one vertex on the origin. It needs to have one vertex on the origin. It needs to have one vertex on the origin. Then I put a comma after origin. It wasn't there before. I needed to plot a point at -3 and +5, and the square needs to have a perimeter of 20. You'll notice that I plotted 5 points. I plotted 5 points because I needed to have one point plotted at -3 and +5. That was only going to form a rectangle, so I had to put a point at -5, +5, -5, 0, 0, 0, and 0, 5 in order to have a square that has a perimeter of 20. Number 3. A. Plot and connect the following points to form a polygon. Here you can see I plotted -3, +2 by moving 3 places to the left along the x-axis horizontally, and then 2 places vertically along the y-axis. Now in green you can see that I've plotted the point 2 and 2. So I moved 2 to the right along the x-axis horizontally and 2 vertically along the y-axis. In blue you can see the point plotted for 2 and -4. I moved 2 to the right along the horizontal axis or the x-axis and 4 down along the y-axis or the vertical axis. Next, in purple, I plotted the point for the coordinates -1 and -4, moving 1 to the left along the x-axis and 4 down along the y-axis. Next, I plotted the coordinates -1 and -2, moving left along the horizontal axis 1 unit and moving down along the vertical axis 2 units. I plotted -3 and -2 by moving 3 units to the left along the horizontal axis and 2 units down along the vertical axis. And finally, I plotted the last set of coordinates, which were exactly the same as the first set of coordinates, -3, and +2. Again, I started at the origin, and I moved to the left 3 units along the horizontal axis, and then I moved up 2 units along the vertical axis. Here's a look at the polygon after I connected the dots. B. Find the perimeter of the polygon. To find the perimeter of the polygon, I need to add up all the lengths, or I can count every unit along each length and total them up. 4 plus 5 plus 6 plus 5 plus 2 plus 2 equals 24. The perimeter of the polygon is 24 units. Number 4. For each situation, select all the equations that represent it. Choose one equation and solve it. A. Jada's cat weighs 3 4/45 kilograms. Andre's cat weighs 1 2/10 kilograms more than Jada's cat. How much does Andre's cat weigh? This first equation represents it. X equals 3 4/45 kilograms plus 1 2/10 kilograms. And there the X represents the weight of Andre's cat. This next equation does not represent the situation, as Andre's cat weighs more than Jada's cat, not less than Jada's cat. The third equation also doesn't represent the situation, as Andre's cat does not weigh less than Jada's cat. The last equation does represent the situation, as Andre's cat minus 1 2/10 kilograms equals the weight of Jada's cat. They're asking me to choose one equation and solve it. I'll go ahead and solve for the first equation. X equals 3 4/45 plus 1 2/10. 3 4/45 plus 1 2/10 equals 4 65/100. Andre's cat weighs 4 65/100 kilograms. B. Apples cost $1.60 per pound at the farmer's market. They cost 1 5/10 times as much at the grocery store. How much do the apples cost per pound at the grocery store? The equation that best represents this situation is y equals 1 5/10 times 1 60/100. 1 5/10 times 1 60/100 equals 2 90/100. Apples cost $2.90 per pound at the grocery store. Unit 7, Lesson 16. Common Factors. Number 1. A teacher is making gift bags. Each bag is to be filled with pencils and stickers. The teacher has 24 pencils and 36 stickers to use. Each bag will have the same number of each item with no items left over. For example, she could make 2 bags with 12 pencils and 18 stickers each. What are the other possibilities? Explain or show your reasoning. 24 and 36 are both divisible by 2, 3, 4, and 6. I've made a chart or a table to help me through this. One bag has 24 pencils and 36 stickers. 2 bags has 12 pencils and 18 stickers. 3 bags has 8 pencils and 12 stickers. 4 bags has 6 pencils and 9 stickers. And 6 bags has 4 pencils and 6 stickers. Number 2. A. List all the factors of 42. 1 and 42, 2 and 21, 3 and 14, and 6 and 7. All the factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. In blue, you see the 1 and 42 because 1 times 42 equals 42. In green, I have 2 times 21 equals 42. In red, I have 3 times 14 equals 42. And finally, in purple, I have 6 times 7 that equals 42. Those are all the factors of 42. What is the greatest common factor of 42 and 15? Again, here I've listed the factors of 42, and below I've listed the factors of 15. The factors of 15 are 1, 3, 5, and 15. 1 times 15 equals 15, and 3 times 5 equals 15. These are the factors of 15. The greatest common factor of 42 and 15 is 3. C. What is the greatest common factor of 42 and 50? Again, here we see the factors of 42, and beneath it I have the factors of 50. 1, 2, 5, 10, 25, and 50. So we need to look for the greatest common factor. Which numbers do they have in common, and which is the largest one that they have in common? Well, it's not very large, but it's the largest one that they have in common. The greatest common factor of 42 and 50 is 2. Number 3. A school chorus has 90 6th grade students and 75 7th grade students. The music director wants to make groups of performers with the same combination of 6th and 7th grade students in each group. She wants to form as many groups as possible. A. What is the largest number of groups that could be formed? Explain or show your reasoning. The first thing I did was write down the factors of 90 and write down the factors of 75. Next, I looked for the greatest common factor, and the greatest common factor of 90 and 75 is 15. 15 is the largest number of groups that could be formed. B. If that many groups are formed, how many students of each grade level would be in each group? 90 6th grade students divided by 15, and 75 7th grade students divided by 15. Look to the top of the screen where I have the factors of 90, and you'll see that 90 divided by 15 equals 6, because 6 times 15 equals 90. Look underneath it where you see the factors of 75, and you'll discover that 5 times 15 equals 75, or 75 divided by 15 equals 5. If 15 groups were formed, there would be 6 6th graders in each group and 5 7th graders in each group. Number 4. Here are some bank transactions from a bank account last week. Which transactions represent negative values? Monday, $650 paycheck deposited. That's not a negative, that's a positive because it was deposited. Tuesday, $40 withdrawal from the ATM at the gas pump. That's a negative because money was withdrawn. Wednesday, $20 credit for returned merchandise. That's a positive because merchandise was returned and $20 was credited back to their account. Thursday, $125 deducted for cell phone charges. That's a negative because $125 was deducted from the account. Friday, $45 check written to pay for book order. That would be a negative because a check was written to pay for a book order, and the money would be taken out of the account. Saturday, $80 withdrawal for weekend spending money. That's also a negative because $80 was withdrawn, which means money is taken out of the account. Sunday, $10 cashback reward deposited from a credit card company. That's a positive because $10 cash was deposited into the account. The transactions that were negative were Tuesday, Thursday, Friday, and Saturday. Number 5. Find the quotients. A. 1/7 divided by 1/8 equals 1/7 times the reciprocal of 1/8. And 1/7 times 8 over 1 equals 8/7, or 1 1/7. B. 12/5 divided by 6/5. That's equal to 12/5 times the reciprocal of 6/5, which is 5/6. 12/5 times 5/6 equals 60/30, or 60 divided by 30, which is equal to 2. C. 1/10 divided by 10. That equals 1/10 divided by 10 over 1, and 1/10 divided by 10 over 1 equals 1/10 times the reciprocal of 10 over 1, which is 1 over 10. So 1/10 times 1/10 equals 1/100th, or 1 over 100. D. 9/10 divided by 10/9. That equals 9/10 times the reciprocal of 10/9, which is 9/10. 9/10 times 9/10 equals 81/100, or 81 over 100. Number 6. An elephant can travel at a constant speed of 25 miles per hour, while a giraffe can travel at a constant speed of 16 miles in 1/2 hour. A. Which animal runs faster? Explain your reasoning. First, take a look at the constant speed of the giraffe. It travels at 16 miles in a 1/2 hour. So 16 miles in a 1/2 hour is the same as 32 miles in 1 hour. And 25 miles is less than 32 miles. So the giraffe travels faster than the elephant. B. How far can each animal run in 3 hours? The rate that the elephant runs is 25 miles in 1 hour, and the rate that the giraffe runs is 32 miles in 1 hour. For the elephant, I'll make a chart with miles on the left side and hours on the right side. The information says that the elephant travels 25 miles in 1 hour. To find out how far the elephant travels in 3 hours, I'll have to multiply 1 times 3 to make 3 hours, and I also need to multiply the number of miles by 3. 25 miles times 3 equals 75. So in 3 hours, the elephant can travel 75 miles. Next, I'll make the same type of chart for the giraffe. The information tells me that the giraffe travels 16 miles in a 1/2 hour, which is the same as 32 miles in 1 hour. In order to figure out how far the giraffe can travel in 3 hours, I need to multiply 1 hour times 3. Since I multiplied the hours by 3, I also need to multiply the miles times 3. 32 times 3 equals 96. In 3 hours, the giraffe could travel 96 miles. Unit 7, Lesson 17, Common Multiples. Number 1A. A green light blinks every 4 seconds, and a yellow light blinks every 5 seconds. When will both lights blink at the same time? Look at the bottom and you'll see that I've listed the multiples of 4 all the way up through 40, and the multiples of 5 all the way up through 40. And starting from smallest to greatest, you'll notice that 20 is the first common multiple, making 20 the least common multiple. So every 20 seconds, both lights will blink at the same time. The green light and the yellow light will blink at the same time every 20 seconds. 20 seconds, 40 seconds, 60 seconds, and so on. And that's because the least common multiple of 4 and 5 is 20. B. A red light blinks every 12 seconds and a blue light blinks every 9 seconds. When will both lights blink at the same time? I made a list of some of their multiples, and now I need to search for the least common multiple. I noticed that the least common multiple for 12 and 9 is 36. So the red light and the blue light will blink at the same time every 36 seconds, at 36, at 72, and so on. The red and blue light will blink at the same time every 36 seconds because 36 is the least common multiple of 12 and 9. C. Explain how to determine when 2 lights will blink together. Well, to figure out when 2 lights would blink together, you determine what their least common multiple is. Number 2. A. List all multiples of 10 up to 100. To list multiples, you just count by that particular number. For example, to list multiples of 10, you'd count by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. B. List all multiples of 15 up to 100. It's the same idea. We're going to count by 15. 15, 30, 45, 60, 75, and 90. C. What is the least common multiple of 10 and 15? Well, let's look at the multiples of 10 and look at the multiples of 15 and find the numbers that are in common and then select the smallest one. The smallest multiple that they have in common, or the least common multiple, is 30. The least common multiple of 10 and 15 is 30. Number 3. Cups are sold in packages of 8,
Napkins are sold in packages of 12. A. What is the fewest number of packages of cups and the fewest number of packages of napkins that can be purchased so there will be the same number of cups as napkins? I've listed a few of the multiples of 8 and I've listed a few of the multiples of 12. Now we need to look for the least common multiple. The least common multiple of 8 and 12 is 24. 24 is the third multiple of 8, and 24 is the second multiple of 12. So you'd have to buy 3 packages of cups and 2 packages of napkins. B. How many sets of cups and napkins will there be? Originally the word was plates, but I crossed it out and wrote cups because we're talking about cups and not plates. There will be 24 sets of cups and 24 sets of napkins. Number 4. Rectangle ABCD is drawn on a coordinate plane. A equals -6 and 9, and B equals 5 and 9. What would be the locations of points C and D? Well, the location for C could be at 6 and -9. And the location for D could be at 5 and -9. Number 5. A school wants to raise $2,500 to support its music program. A. If it has met 20% of its goal so far, how much money has it raised? I decided to build a table with the dollar goal on the left and the percent of the goal on the right. $2,500 is 100% of the goal. I'd like to divide 100% by 100 to figure out what 1% of the goal would be. 100% divided by 100 equals 1%. And since I divided the right column by 100, I have to divide the left-hand column by 100. 2,500 divided by 100 equals 25. So 1% of the goal would be $25. If they met 20% of their goal, we could figure out the dollar amount now by multiplying 1% times 20. 1% times 20 equals 20%. Now we need to multiply 25 times 20, and 25 times 20 is 500. So 20% of the goal would be $500. If they met 20% of their goal so far, then they would have raised $500 so far. B. If it raises 175% of its goal, how much money will the music program receive? Show your reasoning. Let's use the information that we discovered while using the table. 1% equals $25, and we can multiply this 1% by a number to get 175%, and we'll multiply 25 times that same number to get the unknown amount. 1% times 175 equals 175%. 25 times 175 equals 4,375. So if the school raises 175% of its goal, the music program would receive $4,375. Unit 7, Lesson 18. Using common multiples and common factors. Number 1. Mai, Claire, and Noah are making signs to advertise the school dance. It takes Mai 6 minutes to complete a sign. It takes Claire 8 minutes to complete a sign. And it takes Noah 5 minutes to complete a sign. They keep working at the same rate for a half hour. A. Will Mai and Claire complete a sign at the same time? Explain your reasoning. Claire completes a sign every 6 minutes, and the multiples of 6 are 6, 12, 18, 24, 30, and anything after 30 is after a half an hour and it won't count anyway. Claire completes a sign every 8 minutes, and the multiples of 8 are 8, 16, 24, 32, and 40. The 24th minute, both Mai and Claire will complete a sign at the same time, since 24 is a common multiple for 6 and 8. B. Will Mai and Noah complete a sign at the same time? Explain your reasoning. Mai's multiples are still 6, 12, 18, 24, 30, and so on. I mistakenly underlined Noah's name in green. I should have underlined Noah with red. So look at the bottom and you'll see the multiples of 5. 5, 10, 15, 20, 25, and 30. The least common multiple of 6 minutes and 5 minutes is 30 minutes, and that's right at the deadline since they were only working for a half hour. So the answer would be yes. On the 30th minute, Mai and Noah will complete a sign at the same time. C. Will Claire and Noah complete a sign at the same time? Explain your reasoning. Well, I said no because the least common multiple for Claire and Noah is 40, and 40 minutes is beyond a half hour. D. Will all 3 students complete a sign at the same time? Explain your reasoning. The answer is no, and my reasoning is that if Claire and Noah can't complete a sign at the same time within the half hour, then all of the students cannot complete a sign at the same time within a half hour. Number 2. Diego has 48 chocolate chip cookies, 64 vanilla cookies, and 100 raisin cookies for a bake sale. He wants to make bags that have all 3 cookie flavors and the same number of each flavor per bag. A. How many bags can he make without having any cookies left over? I made a table with the number of bags on the far right-hand column, the number of chocolate chip cookies on the left, the number of vanilla cookies in the middle, and the number of raisin cookies to the right of the vanilla cookies. The information that they gave us said that there were 48 chocolate chip cookies, 64 vanilla cookies, and 100 raisin cookies. If you were to stick all those cookies in one bag, you'd have 48 chocolate chips, 64 vanilla, and 100 raisin. If you were to divide those cookies up into 2 bags, you'd have half of 48, which is 24 chocolate chip cookies, half of 64, which is 32 vanilla cookies, and half of 100, which is 50 raisin cookies, and that's in 2 bags. 48 chocolate chip cookies divided by 4 bags would be 12, 64 vanilla cookies divided by 4 bags would be 16, and 100 raisin cookies divided by 4 bags would be 25. Diego can divide all of his cookies between 4 bags without having any left over. Number 3A. Find the product of 12 and 8. Finding the product means we have to multiply, so 12 times 8 equals 96, or the product of 12 and 8 is 96. B. Find the greatest common factor of 12 and 8. I've listed the factors of 12, which are 1, 2, 3, 4, 6, and 12, and I've listed the factors of 8, which are 1, 2, 4, and 8. The largest of those common factors, or the greatest common factor, is 4. So the greatest common factor of 12 and 8 is 4. C. Find the least common multiple of 12 and 8. I've listed the multiples of 12, 12, 24, 36, 48, and so on. And I've listed multiples of 8, 8, 16, 24, 32, and so on. The least common multiple of 12 and 8 is 24, as 24 is the smallest multiple that they have in common. D. Find the product of the greatest common factor and the least common multiple of 12 and 8. Remember, finding the product means multiply. So we're going to multiply the greatest common factor, which was 4, and the least common multiple, which was 24. So 4 times 24 is 96. E. What do you notice about the answers to question number 1, which was question A, and question number 4, which was question D? The product is the same for both question A and D. F. Choose 2 other numbers and repeat steps 1 through 5. Do you get the same results? The 2 numbers that I chose were 4 and 20, and the product of 4 and 20 is 80. The least common multiple for 4 and 20 is 4. The greatest common factor for number 4 and number 20 is 20. The product of 4 and 20 is 80. So yes, I got the same answers as I did before. The product of 4 and 20 is the same as the product of the greatest common factor of 4 and 20 and the least common multiple of 4 and 20. Number 4A. Given the points 5 5/10 and -7, name a second point so that the 2 points form a vertical segment. I drew a little vertical segment on the right-hand side of that sentence. The second set of points that would help form a vertical segment would be 5 5/10 and +7. Any set of coordinates would work as long as the first number in the set of coordinates was 5 5/10. B. Given the point 3 and 5/10, name a second point so that the 2 points form a horizontal segment. I drew an illustration of a horizontal segment. The set of coordinates -3 and 3 5/10 would form a horizontal segment along with 3 and 5/10. Number 5. Find the value of each expression mentally. A. 1/2 times 37 minus 1/2 times 7. You can use the distributive property. 1/2 times 37 minus 7. And that's the same as 1/2 times 30, or half of 30. And half of 30 is 15. B. 3 5/10 times 40 plus 3 5/10 times 60. You can use the distributive property here too. 3 5/10 times 40 plus 60, or 3 5/10 times 100. And 3 5/10 times 100 is 350, which is 100 times larger than 3 5/10. C. 999 times 5. 999 is almost 1,000, so we can call it 1,000 times 5. But then we need to subtract 5 for that 1 that we added, and that 1 was multiplied by a 5. So 1,000 times 5 minus 5. That would be 5,000 minus 5. And 5,000 minus 5 is 4,995. So 999 times 5 is 4,995.